Okay, welcome everyone. I'm Barry Goodison. I'm chair of the Ottawa CMOS Center, and really glad that you could join today wherever you may be located, be it Ottawa or Winnipeg or other places. Just a couple of housekeeping notes. First of all, I think many of you are on it. If you can have your video and your microphone off, that helps a lot in the presentation. We don't pick up extraneous noises since most are still at home. I'll note that the question and answer session at the end, it'll be handled by Pat McCarthy. And we ask you to, if you have any questions, to type them into the chat function, and he will filter through those and make them, read them out to the speaker. That way we can keep the presentation on the screen if need to go back to show something, or we can combine questions as appropriate. So that's the mode we'll use rather than people verbally asking their question. And want to note that the session is being recorded, and it will be posted onto the CMOS YouTube channel in a few days. And so you, at any time, you can go back and look at things that you might want to look at in more detail, or let others know that it's available there. So as I say, welcome from the Ottawa Center, and I'd like to turn it over to the Winnipeg Center at the moment, and Pat McCarthy, their chair. Pat.
Thanks, Barry. Hello, welcome everyone. I'm Pat McCarthy, chair of the CMOS Winnipeg Center, and it's a great opportunity for us to, we're a small center, to participate and co-host this talk with Ottawa Center. Now our guest works out of the world famous Freshwater Institute here in Winnipeg. And so with that, I'd like to pass this over to Helen Joseph, who will introduce our guest speaker.
Good morning, everyone, and thank you. Yes, it's my pleasure to introduce you to Dr. Andrea Niemi of Fisheries and Oceans Canada. I guess you could say DFO is my alma mater for the most part. Andrea is a research scientist in the Arctic and Aquatic Research Division, as was mentioned, in Winnipeg, Manitoba, and she spends a considerable bit of her time in Iqaluit, Nunavut under normal circumstances. Andrea's research experience began in the Experimental Lakes area, that's in Kenora, Ontario, and she slowly migrated northwards from there, moving from the Arctic freshwater into Arctic marine lower trophic studies. Andrea received her master's from Simon Fraser University, where she conducted research on lower trophic studies in the Mackenzie Delta Lakes area that experienced different frequencies in their riverine flooding. She moved on to obtain her PhD from Université de Québec at Rimouski, focusing on microbial-mediated organic carbon cycling associated with Arctic sea ice. As part of Andrea's PhD work, she was fortunate to participate in the maiden scientific voyage of the Canadian Coast Guard ship Amundsen when it sailed from Quebec City to the Beaufort Sea. Normally, Andrea would be working in the labs at the Freshwater Institute, but during the pandemic, of course, she remains working from home. Here she has two young sons with whom she's already educating in Arctic facts. She tells me that she's telling them things that polar bears and penguins do not, in fact, live together. So we look forward to getting some more information along those lines. Welcome very much, Andrea, to the CMOS Ottawa Center. We look forward to hearing from you. Thank you.
Hey, thank you very much for that introduction. Yes, it's a pet peeve of mine seeing polar bears and penguins put together. So I really appreciate the opportunity to speak today, and I'm just going to make sure I can advance my slides. There we go. So yeah, talking about the variability of forage species and really understanding what's happening with forage species is really important, since they are central to energy transfer within the marine environment. And therefore, they're important for ecosystem health and stability overall. So I'd really like to thank my co-authors who for their highly valuable contributions to this talk and their knowledge sharing through the process of preparing this talk. I would like to acknowledge that this work has taken place in Inuit Nunangat, the homeland of Canada's Inuit, which includes the land, water, and the ice. And specifically, this work was done in the Inuvialuit settlement region. And I really want to thank all the co-management boards who have been involved over many years, and the community members have supported the work in so many ways and directly delivering the science. It's always a great opportunity to be able to work and learn together.
Andrea?
For this talk, I'll be,
Andrea,
yes.
maybe you should turn off the video, the audio, the video. It is interrupting as we suspected.
Yeah, I'm gonna shut my video. All right. So I'm going to be presenting 4 segments kind of for this talk. First of all, looking at how we are assessing forage species variability. Then looking a bit more specifically at sea ice, given its central role in the status of forage species. And then move on to a couple of specific examples of responses of forage species to sea ice and associated drivers. And then to end, just a really brief look at issues associated with connections to the Pacific. And through this talk, I'm going to be showing a variety of data, and it comes from different sources that I'd like to acknowledge. Much of the oceanography comes from Humphrey Malling's long-term mooring work in the Beaufort. It's been called many different program names over the near 40 years, and it's a hugely valuable data set for looking at variability in ocean conditions. I'm also presenting data analysis from ASL Environmental Sciences, looking at different components of sea ice. And for the biological data, the majority of it comes from the Berea Marine Fishes Project, which ran from 2012 to 2014. And then we were able to get it going again and rebranded it as the Canadian Beaufort Sea Marine Ecosystem Assessment, or CBS-MIA. And it ran from 2017 to 2019, of course, the break for 2020, but we're looking forward to being back on the water this year. And this program is delivered off a research trawler shown here called the Frosty. And it comes up from BC to the Beaufort to do this work. And it's CBS-MIA is a comprehensive offshore program where we look at throughout the ecosystem. It includes the usual rosette and CTD sampling, various zooplankton nets, box coring, hydroacoustic transects data collection, as well, of course, as bottom and midwater trawls. So to start, I'm just trying to advance my slide. Sorry for the delay. Okay, so how are we assessing forage species? Well, first of all, we're working, of course, towards building adequate time series to get a measure of the range of variability of different parameters. And as part of CBS-MIA, we have identified priority transects that we try to sample each year. And we also try to revisit key embayments, including Franklin Bay, has a good history from previous studies, as well as Minto Inlet, which may not be as well known, but it's an interesting place, has a deep trough, and we found good aggregations of Arctic cod in there. And here's 3 years of data that shows interannual variability of fish there. And we see variability with respect to biomass present, as well as community composition. And as you can see here, Arctic cod is the major biomass contributor, and it really is a key forage fish species in Minto Inlet, but also elsewhere in the Amundsen Gulf and on the shelf. So it's really actually quite helpful to have one really key forage fish species to focus on to identify potential key changes in the food web for several subsistence and key predator species, including beluga. Here's another example showing spatial and temporal variability of benthic Epifauna and Infauna. And this is running from Cape Bathurst over to Banks Island. And we have a working hypothesis of how the observed variability is related to upwelling and changes in sea ice conditions, although the time series even that we have here is really too short to identify clear patterns and relationships. There's still a lot of complexity throughout the system. To assess forage species variability, we really need to expand from our limited summer view. There's really too many important life history events and other occurrences that occur outside of the summer period. For example, there can be key periods of cod spawning as early as January. So as part of CBS MIA, we've started the deployment of more biological moorings, where we pair active and passive acoustics to look at seasonal patterns of zooplankton and cod, and linking them on up to marine mammal detections. And really, we're just getting into these analysis, but they can expand our annual view. Another way that we're working on looking at forage species is to take a functional approach to assessing the different species and considering the ecosystem function of species, not just their biomass or abundance number. We're working on building a trait inventory, and this work is led by Ashley Ehrman in our group, in which really summarizes the feeding habitats, mobility, and size of many species. We're over 200 species now, looking at key forage species of fish, benthic invertebrates, and zooplankton species. And the traits, we can assess the trait diversity over our spatial and temporal scale. And here, I find it interesting that the red color indicating trait diversity hotspots at locations other than Cape Bathurst, which is frequently discussed as an ecosystem hotspot, but we can see other key diversity areas within the system. We've also been collecting data on biotracers, and so we can assess stable isotope diversity to inform feeding diversity and the roles of different forage species. During BRIA and CBS MIA, Ashley has used stable isotopes to map food web structure and connections in different locations. And this one is from Darnley Bay, showing Arctic cod situated centrally within the food web. So we see nitrogen stable isotopes on the left and carbon on the right, and presented for fish, Epifauna, Infauna, zooplankton, and the sediments. So with such information from multiple locations or times, we can look for changes in food web structure, and we can also determine if the isotope or other signatures of forage species is changing. And this is key to answer questions for higher trophic levels. For example, there's indications that diet of beluga could be changing, but is that simply because the signal of Arctic cod is changing because of shifts from ice associated to pelagic food sources? So this is something we're currently working with and connecting with the marine mammal group. So there's many ways that we can assess forage species, and it's fantastic to have the data that we do have. But putting all the pieces together is an ongoing process, and we're trying to gain a better understanding of these key species at a time when their environment continues to be highly variable and changing. So So now I'll take a kind of a shift and take a look at how the world around these species is looking specifically with respect to sea ice. And I know we hear so much about the decline in sea ice, but the 2018 sampling season certainly really reminded us that we're still working within the Arctic, and the ice is still there. So to start here, we're looking at the Mackenzie region analysis and out on the shelf. And in the last 19 years, all sea ice types on the Mackenzie shelf has declined in concentration. There's been almost a 10% decrease for all ice and a slightly lower decrease for seasonal ice, with more seasonal ice in the winter due to the reduction of the old multi-year ice. Between 2000 and 2019, what's shown here, we're still seeing a decline in the old ice, with the old ice presence decreasing from about 11% to 6% of the sea surface. So these are still strong decreases that we're seeing. And here we're looking at trends in the timing of freeze up and breakup. And the clearance and freeze up events have been simplified by tracking the transition across 7/10 ice. So I know we can look at different values, but here's 7/10 ice. And we're seeing a later freeze up of almost 10 days and an earlier breakup of almost 30 days since the year, just since 2000. So this is looking from 2000 to 2019. So from an ecosystem perspective, that earlier breakup of almost a month, I feel is hugely significant for species who are really evolved to an ice-dominated ecosystem, especially key events of the spring bloom and ice-associated algae. The ice certainly melts in this region, although spring ice clearance is largely affected by the ice movement. And really overall, the period with more open mobile ice has lengthened by 70 days in only 19 years. And these trends, of course, do include a lot of variability. So for example, this shows the trend in percent ice coverage specifically on June 18th from 2000 to 2018. And here the ice is decreasing at a rate of 21% per decade, but with an interannual variability of 35%. So still lots of variability within these trends. And based on this specific analyses, ice is clearing about 54 days earlier here. And really a key mechanism by which the ice has cleared earlier is the faster and or more consistent ice drift to the west-northwest, which is the result of a stronger Beaufort anticyclone during this time period. So there is melt, but the clearance, the wholesale movement of ice is significant as well. So what about the Amundsen Gulf? A lot of our work is situated in there. So here's similar plots looking at the 7/10 ice transition, 7/10 ice analysis for breakup and freeze up dates in the Amundsen West ice analysis zone. And there's certainly high variability, and the trend is not significant, even though we see declines. And what got sold there is the 2018 sea ice in summer, where we had the ship in the ice like that. So there's still certainly occurrences of ice coming into the area. But I would not want a a plot like this to be used to say that the ice is not changing in the region, and that's not true. Variability and change is very alive and well, and the community see it and are certainly experiencing it. The key point is that throughout the Canadian Beaufort Sea region in general, ice is clearly changing with respect to the ice season, and there will certainly be differences between ice analysis domains and how the analysis needs to be done. And attention does need to be paid to the small scale ocean to really understand drivers that are important and are relevantly locally for species and the ecosystem. To wrap up the sea ice part here, just a few points on mechanisms driving the variability and change that we're seeing. And one thing specific to the shelf region is the freshet of the Mackenzie River, the period of peak flow from the Mackenzie River, which is the driver specific to the shelf. There really hasn't been a significant change in river volume, but the timing of freshet is occurring earlier, which is promoting and enabling earlier ice clearance on the shelf. So the timing of that freshet is important. And of course, the preconditioning to younger and thinner sea ice is very important. This has been known for some time, that the system is preconditioned to further sea ice change, given the younger and thinner ice pack that is more reactive to winds and fracturing and susceptible to solar absorption. And also, of course, the winds are extremely important in they're hugely important and variable. And winds are variable, of course, on the short and long time scales. And in the 2000, easterly winds were predominant during the summer, resulting in the net transport of sea ice. And this was linked to both the record low summer sea ice years and the lengthening of the opening water period. However, in recent years, westerly winds have become more common. And here's those years in the 2000s where we're seeing the winds from the east being predominant in the system and really affecting the net offshore transport of the sea ice in the system. But again, in more recent years, we're starting to see a change. And here we see the salinity at the seabed at two locations on the Mackenzie shelf. One from the mooring out at the 115 meter isobath, and the other one closer in at the 55 meter isobath, and showing from back in 97 through to 2019. And of course, there's lots of variability with upwelling and downwelling, and the downwelling being indicated in blue. And now in recent years, we're seeing more of the prevalence of westerly winds causing downwelling. And you can see that starting kind of from 2016 onwards. And from a research perspective, I kind of grew up in the Beaufort during the period of easterly winds at a time when I was focusing on a lower trophic dynamics. I was well aware of the importance of upwelling, and that was brought by the easterly wind. There's lots of talk about upwelling and recognizing the importance for the system. Now, looking at the recent data, I'm finding that I'm also quite a fan of the westerly winds, and I'm interested to see how the ecosystem responds to the corresponding shift in ice motion and associated downwelling. So from here, I'd like to take a look at a couple forage species examples that fall within different ice forcing periods. So starting with talking about Arctic cod, and here's a really wonderful Arctic cod data set from ship-based acoustics. And this is work from connecting work from ArcticNet as well as the BRIA CBS MIA project. And this is led by Maxime Geoffroy at Memorial University. And you can see that there's quite evident, variability with 2014 showing a serious decline or crash, as I call it, not necessarily a crash, but what's happening? Is this really a change in population size, or has the fish just moved to a different location? And if we look at this 2014 year, we can see that the older age 1+ fish down at the deeper layer really weren't there at all in 2014, very little. And even the young of year fish up in the surface water was much reduced in 2014 compared to 2017. And it's possible that you could say, well, the fish were just in another location, but from our extensive sampling in 2014, it was evident it wasn't just a shift in distribution within Amundsen Gulf or out on the shelf. That really was a decline in the population in that area. And the 2014 biomass is a reflection of a decline in the age 1 cod in the mesopelagic layer, as well as lower numbers of the young of year fish in the upper epipelagic layers. So if we look at the years leading up to the serious decline or the kind of that crash in cod, we know that 2012 was a record low summer sea ice year. And then in 2013, there was quite a delay in breakup with still lots of snow cover. And this led to a documented mismatch between adult copepods and ice algae food resources. So really limited the copepods that year. And the young stages of the copepods that were much reduced are key prey for the larval Arctic cod. So there was this mismatch that happened in early 2013. Another thing that happened towards the end of 2012 is that there was strong downwelling, given that there was such thin ice cover following that record low sea ice year. And there was quite extensive downwelling extending even into early December. So this could have created quite a barrier to the nutrient layer in the Pacific waters into spring. The opposite has certainly been documented, where fall upwelling has preconditioned conditions for higher productivity in the spring. And so not only could there was the delay in ice off in 2013, but the water column could have also been preconditioned to lower productivity because of the downwelling. So what about zooplankton during this time? When we look at them specifically from the BRIA project, we do see that there was quite a decline in total zooplankton numbers in 2013, as well as the nauplii, the larval stages of the zooplankton. 2013. So, but there was quite an increase in 2014. So zooplankton forage species were certainly available for Arctic cod in 2014. So the decline in cod was certainly not a within-year response to food resources, and that really wasn't expected. But it is interesting to note that the zooplankton bounced back so well in 2014, despite the mismatch that occurred in 2013. And this resiliency likely linked to the multi-year life cycle of the copepod zooplankton. They really don't, have all their eggs in one basket, so to say, for reproduction from year to year. But we did see that we can say that the poor recruitment and survival of Arctic cod from 2013 to 2014 likely was supported by limited zooplankton availability in 2013. During that decline, especially limited availability of the smaller zooplankton species for larval cod, the smaller nauplii. But also with that, the colder sea surface temperatures in 2013 has also been shown to affect the survival and recruitment of cod from 2013 into 2014. So it was quite the perfect storm of reduced prey availability as well as colder sea surface temperatures affecting the survival and growth of cod from 2013 to 2014. But it is interesting to note the higher biomass of cod in 2016 and 17. And so, we can start asking questions about why did this happen? And one suggestion is, could this be related to the increase in downwelling events that we've started seeing? One hypothesis is that the westerly winds can work to stock embayments in Amundsen Gulf with not just the Arctic cod larvae, but also their food resources, and thereby supporting better recruitment for the system overall. And so we can get a kind of a first look at this from some recent AZFP data, the acoustic zooplankton fish profile instruments that we have deployed around Cape Bathurst. And this is showing results. We had July to September period of 2018. And this is moored at Cape Bathurst at about 50 meters depth. Here I'm showing 3 frequencies from the ZFP, the 38 and the 200, which tells us about fish and larger zooplankton, as well as the 455, that frequency that tells us more about the smaller zooplankton and copepods. And so the top panel there, it's showing indices of up and downwelling. So we can see that there's quite a bit of downwelling. And this corresponds to what I had shown previously for the upper slope of the Mackenzie shelf, where again, there was a lot of downwelling during the year in 2018. So I've highlighted a few key downwellings there to see that there is an increase in fish and zooplankton backscatter with these downwelling episodes, and that it's quite a quick response. There doesn't really seem to be the time there to suggest that this is a food web step-by-step process, but more of a transporting, a concentrating of larval fish and the zooplankton. So what could this mean for the area with these downwelling events? What's the fate of these zooplankton fish? Well, of course, this would be quite convenient for marine mammal feedings, and we've seen, concentrating feeding events associated with follow-on activities after upwelling. So this similarly could support things for marine mammals. But also with these downwelling events, we know that, of course, the water doesn't stay there, and ADCP data shows us that there can be quite high current rates with transporting from the east side of Cape Bathurst into Franklin Bay. So when we've looked at zooplankton abundance comparing Franklin Bay to Cape Bathurst, we see during this period in 2018 in the summer, found that the zooplankton in Franklin Bay were about 3.5 times higher than at Cape Bathurst. So it's a possibility that there is quite good transport and entrainment or entrapment of larval fish and the zooplankton within Franklin Bay, which really does make it this kind of a hot spot of spawning and feeding areas for Arctic cod, which has been suggested in the past. So all this to say that this data is helping us to move towards looking at downwelling as potentially supporting Arctic cod spawning and their rearing habitats in embayments by transporting larvae and supporting food in that area. Okay, so just to end, I did want to talk briefly about the Pacific influence in the area where we've been studying, Canadian Beaufort Shelf and in Amundsen Gulf. And in recent years, because of changes going on in the Chukchi and Bering sectors, warming and various other things, been looking for characteristics of Pacific coastal waters over in the Canadian Beaufort Sea. So here's data from 3 moorings that can kind of be used to look for or trace Pacific signatures, one out on the Chukchi Plateau, one more on the Beaufort Slope, and one into Amundsen Gulf. And from here, we can look for summer waters that would be leaving the Bering. So that would be leaving the Bering in about June, and that would be arriving in the Beaufort in the Canadian sector in about October. And the profile plots there indicate where the coastal water signal may be identified with those arrows. And we see more, of course, makes sense, more of a Pacific signal in the Chukchi sector. But really there hasn't been a strong signal of recently arrived in coastal water in either 2017 or 18, although there was a weak signal in 2019. One issue, as we are interested in seeing what's happening with these coastal waters and changing characteristics coming into the Canadian Beaufort, is to understand what local solar heating is doing in the Amundsen Gulf region. The sea surface temperatures have been increasing, and that these might mask the signals looking at them through temperature and salinity characteristics. So to continue tracking these, it might be much better to shift to looking at nutrients if in an ongoing way to try to track these changes potential in the Pacific signal. Of course, the Bering Sea winter water is certainly evident in a key consistent feature on the Mackenzie Shelf and in the Amundsen Gulf. And this plot shows 19 years of temperature and salinity data for the winter Bering Sea water layer. And this marine site is at 105 meters on the shelf, and also at another mooring at the 50-meter depth. We really see no long-term trend in warming at either the 50-meter or 100-meter depth. But we do know that this Pacific halocline is very important, as it holds the major source of nutrients for the area. And another key characteristic of this water layer is that it's naturally undersaturated from a carbonate chemistry perspective. So on the shelf in Amundsen Gulf has relatively low aragonite saturation state compared to other ocean regions, due of course to the colder water temperatures, but as well really because of this inflow of this naturally undersaturated Pacific halocline water. And we know that this layer is quite variable with respect to the saturation state, but it's also declining both in the upper halocline and in deeper waters. And here I'm just showing a recent plot from different regions within Amundsen Gulf Inlet, and straight in at Cape Adams from 2017, showing aragonite saturation with the greens and blues indicating, much of the water column being at or near a value of 1, which indicates a level where shell damage can occur. So we did a study where we assess the Plagix Sea Snail, Lemacina helicina. So it's a small snail, part of the zooplankton. It has a nice aragonite shell. It makes it a good indicator for ocean acidification, which I mean natural as well as anthropogenic sources of ocean acidification. And we looked at the species over 2 different years, 2014 and 2017, which had very different ice opening conditions, ice clearance conditions, as well as summer chlorophyll concentrations. And what we found was that over 85% of the individuals had the most severe type of shell damage. So there's this scale on 3 levels, and the 3rd level indicates really compromised shell integrity and extreme frailness. And in both years, despite the very different environmental conditions, a large majority of the population had severe shell damage. And if we look at the distribution of the dissolution, it was really widespread, and we did not find any significant differences at upwelling areas or within embayments or at Dolphin and Union Strait, representing a gateway area. One interesting thing we did find was that there was an evidence of a shell regrowth or repair mechanism that we found on adult individuals in the Minto Inlet area, and it seems to be a slightly different mechanism than has been found in other areas of the world's Arctic with respect to repair, and so that was something interesting to find. Now we don't know the long-term trends in shell dissolution. It's likely been happening for a long time given the natural conditions of the Pacific halocline in the areas, but it's also likely that it is increasing given changes already observed as well as increasing undersaturation in surface waters as observed in the Central Arctic Ocean. What this study also highlighted is what's the impact of ocean acidification on other species and other life stages as well, including a larval Arctic cod, and that this could be another key stressor that we need to consider for understanding forage species in this system. So it's clear that there's still a lot of interesting and challenging work ahead to describe and explain the status and future conditions of forage species in the Canadian Beaufort Sea. So that's the end, and I just thank you very much for your attention, and I can try to address any questions.
Okay, if people have any questions, go ahead and type them in. And Pat, it's in your hands at the moment.
Okay, so yeah, so if you have any questions, use the chat feature. This way, it will keep things nice and orderly. And while we, so Barry is asking, from Barry, asked a question. Are there similar studies being done in other parts of the archipelago?
I don't, in the archipelago, there's limited long-term repeated studies. In the high Arctic, there's been the newer MAP Last Ice project has been going on for a few years, but the archipelago, I would say, is still a challenge for repeated sampling. I know, ArcticNet tries to hit repeated stations when they're able to cruise through, but Not to the same extent, I would say, although the different research projects that are out there are providing really important information for comparing results to and looking for interregional differences.
Okay, thank you. Actually, I had a question. It's such a complex problem. I'm not even sure. It's amazing that you guys are able to make sense of of all of that. And one of the things that I wondered about was, do you guys like consider tagging certain species? I imagine maybe like the marine mammals are probably being done at some level. But like you were talking about how the cod would move into certain areas and elsewhere. How do you know it's the same cod type of thing? So is there ways that you could tag? Do you tag certain species to help this?
Yeah, that's a really good point. And so we are collaborating with Lisa Lacedo here in Winnipeg, who has been working with communities on tagging programs for beluga whales. So the data from CBS MIA has been directly linked to what they've been finding. So they're seeing the depth to which the whales are diving, and we can provide information on what's there in different years. And so we're linking that way. And the food web information they're collecting, it also really ties in tightly to Lisa's beluga whale work, as well as we try to track things through the food web. When we're seeing potential changes in diets in beluga, but is it the diets themselves that are changing, or is it the signal of the forage species? So we're working together on that. And then there have been groups that have tagged fish, for example, around Ulahuktuk. And on the AZFP moorings that we've put out the trackers to see if we can pick up tagged fish off in those areas. But so far not yet. The tagged fish seem to be hanging a bit closer to shore and not coming out to where our moorings are located at Cape Bathurst or places like Pierce Point. So we ourselves haven't done any tagging, but those linking to those other projects have been really important. But for the movement of cod, we know they move a lot, but when we try to cover these set transects, the ins and outs, and from have shelf representations from the shelf in the Gulf, we really try to catch, the overall understanding of are they there or not. And in 2014, we had a really good sampling year. We had really good coverage of surface area of the regional area, and it was quite clear that the cod were just not there at a regional scale. But the tagging information really does help.
Okay, thanks. Helen Joseph has a question. So it reads, this is more of an operations questions. Were you able to gather data and go into the field in 2020? And the second question, was there a loss of data? And a third question, are there options of having Inuit collect data?
Yeah, those are all good questions. So in 2020, the Frosty, the ship-based program, it didn't happen. It wasn't an appropriate way to get people on and off the ship, and with all the unknowns. However, our moorings, the AZFP moorings, the CTD and hydrophones and other instruments, we were able to recover and redeploy those off the Laurier with the support of staff from iOS. So two individuals went on from iOS and did an incredible amount of work and got our moorings in and out. So we haven't lost any of that acoustic data, so we can keep that time series going. Communities did continue a lot of work for the coastal programs, but for the Frosty program in the areas we go offshore, it's just not where the community members go with their boats. So we still have the community work that was done closer to shore and their observations to see what the year was like, but we do have the nets in the water are missing from offshore in 2020, but we'll have the moorings.
The question about having the Inuit collect data.
Yeah, the different Inuit programs, coastal communities continued their work in the near shore in the coastal areas. So that data would still be available. And there's different community programs linked with Lisa Lassetto's work, Karen Dunmall and Darcy McNichol. So those programs did continue.
Okay, David Fissel has a question. In the summer of 2018, the downwelling and increased acoustic biomass was also accompanied by anomalously high intrusions of summer sea ice. Does the sea ice have an effect on the biomass?
Yeah, it's interesting. The sea ice affects a lot. We've looked at some ADCP data with Humphrey and Bill Williams when we have deep keels of sea ice moving through, and you can see responses from backscatter responses to the deep keels coming up. And so I would say you can get responses to the sea ice moving through, whether the zooplankton are moving in a way to avoid predators or to access ice algae that are there depending on the time of year. And we certainly saw those responses to the downwelling events as well. So 2018 is going to be a really interesting year to piece that all together. But those plots I showed, it would really help to have some indicia of ice information from ADCP or another instrument to overlay that to see with those responses with the downwelling, how those looked with sea ice as well. But even with the sea ice in clear times and when downwelling was happening, we're still seeing those responses. So there could be combined effects, but there is the straight up downwelling response as well.
All right, thank you. Looks like that was the last question. Andrea, thank you very much. Barry has some final words.
Yes, I'd just like to thank you on behalf of Ottawa Centre, Andrea, very much for participating today, and thank the Winnipeg Centre for joining. It was great to be able to have a couple of centres across the country get together, and I hope this can be replicated in the future. I just wanted to mention the last virtual session that we're going to host in the Ottawa series will be on April 29th, a Thursday. Laura Twiddle is the Managing Director of Catastrophe Indices and Quantification Incorporated, or CAT-IQ for short. And it's going to be on the impacts of extreme events on the Canadian insurance industry. So we're pleased to have private sector be engaged with us. And just to remind everyone about the upcoming CMOS Congress on May 31st to 11th of June on climate change risk resilience response. So you can go online on the CMOS webpage, get further information, register, and be ready to participate. So thanks to everyone for participating today, and hope I don't know what it's like across the country, but we've got beautiful weather here in Ottawa. So please enjoy the rest of the day and week. Thanks very much to everybody for participating.